This is the lesson for 1-1, which is dealing with rational numbers. And our essential question today is, how do we write a rational number as a decimal? And tomorrow we're going to be looking at how to write a rational number as a fraction. And so let's take a look at decimals. Well, we have two different types of decimals. We either have a repeating decimal, or we end up having a terminating decimal. Now, a repeating decimal is when we have a fraction such as 32/9, or 32/99, let's say, and that's the fraction form of this decimal. And what happens is the 3 and the 2, when we do the division, always repeats. And so that's why I have these little periods at the end signifying that it goes on forever. Well, there's another way we can write that rather than having to write out 3, 2 a bunch of times. We can also use a repeating bar. That's what we're going to be doing today. So a repeating bar would just be going over the two numbers that are repeating, in this case, the 3 and the 2. If only the 2 was repeating, then I'd just draw the line over the 2. Well, a terminating decimal, such as 8/25, and that's the fraction form for 0.32, when we do the division, we'll find out that we end up with a remainder of 0. And so when we end up with a remainder of 0, that means after the 2, there's no more numbers that need to be written. We could add zeros to the end, but it doesn't change the value of that number. So let's see how we end up changing these fractions to decimals. Well, the first thing you're going to want to do is you're going to want to write a division problem. So I'm going to end up setting it up this way. I'm going to have 11 on the outside of my little fraction or division sign, and I'm going to put the numerator inside. And so one way people have talked about in the past is that if you think of this as a doghouse here, the top dog always goes in the doghouse, and the numerator always goes inside. And we're trying to see how many times 11 goes into 5 is what we're trying to do. Well, 11 does not go into 5, so we're going to end up adding a 0. And then we add the decimal point and another 0 here. And so now we're doing 11 into 50. Well, 11 goes into 50. We've got almost 5 times, but not quite. See, 5 would be 55, so we're going to go in 4 times. Now, another thing I need to always do is bring up that decimal point right away, and then go ahead and do this multiplication of 11 times 4, and that makes 44. Now we subtract, and we have 6 left over. See, 44 from 50 gives me 6. If I go ahead and borrow, you can see that a little bit easier. So now I have a remainder of 6, so I need to continue to go until I end up with a remainder of 0, or I see the numbers repeating. So we're going to bring down that 0 and do 11 into 60. Well, 11 goes into 60 5 times. So we'll bring up that 5 there and multiply. 11 times 5 makes 55. And when we go ahead and do that subtraction, I end up with 5. Now, if you're really careful, you'll notice that we've had a 5 here before, because you see, when I add in that 0 and I bring it down, I've got 50, and we've already done that. See, we've done 11 into 50 before, but we'll do it one more time here. See, 11 goes into 54 times, makes 44. Do the subtraction, we're left with 6 left over, and you see we've had a 6 before left over. And we bring down that 0, and you see 11 goes into 65 times. So you see how we're getting the same numbers repeating. See, 5 times 11 makes 55, and we're going to end right back up at the 5. And so rather than continuing to go forever and ever, what we can do is just rewrite this as a repeating decimal with that repeating bar. So 45 is being repeated, so we're going to write 0.45 repeated. And this is a repeating decimal. And that would be our answer. Well, let's take a look at another problem here. And this one is one in which we have 1 on top and 8 in the denominator. So what we're going to end up doing is we're going to write it as our division problem of 8 going into 1. Well, 8 doesn't go into 1, so we're going to add that 0. And 8 times 0 makes 0. And so we're going to be left over with 1. But in order to continue, we're going to add a decimal point and a 0. So we're going to bring that decimal point straight up and bring this 0 down. Now we're going to think of this as now 10 rather than 1. And so 8 goes into 10 now 1 time. And that leaves us with 2 left over. So we're going to continue to go until we get a 0 as a remainder or until we see it repeat. So now we're doing 8 into 20. Now 8 goes into 20, we have 2 times because that'll make 16. Do the subtraction, I'm left with 4 left over. So I add another 0, bring down that 0, and now 8 into 40 goes 5 times. And this time, when I go ahead and multiply 8 times 5, I end up with 40. So I ended up with a remainder of 0. So when we have a remainder of 0, that means we have a terminating decimal. So our answer is going to be 0 and 125 thousandths is the way we read that. This 0 is in the ones place. The 1 is in the tenths place with a th at the end. The 2 is in the hundredths place, and the 5 is in the thousandths place. So we read it as 125 thousandths, and that is a terminating decimal. That would be our answer. Well, let's take a look at the next one here. We've got 4/5, so we're going to set up our division problem and see how many times 5 goes into 4. Well, it doesn't, so we're going to add a 0, and when I go ahead and do that subtraction, I'm left with 4 left over, so that means I'm going to add that decimal point and bring it straight up into the quotient, and then bring the 0 down, and now do 5 into 40. Well, 5 goes into 40 8 times, evenly, because you see 8 times 5 is exactly 40. So I have a remainder of 0. And so what that means is we have a terminating decimal. And we read this answer, or this decimal, as 8 tenths, because 8 is in the tenths place. So you're just basically reading off the number in the decimal on the left hand or the right hand side of the decimal, and then you say the last digit's place value is how you read it. And so this is a terminating decimal. Well, looking at our last one, it looks a little different because we have this 2 out in front. So I'm going to change it to an improper fraction. Right now it's in the mixed number form. We've got a whole number and a fraction right here. And so pretty much it's the same thing as saying like 2 plus 1/3. And so if I was to change this to a improper fraction, I'm going to end up multiplying the 2 times the 3 and then adding the 1. 2 times 3 and then adding the 1. And then it's always over the same denominator. And so it's over 3. So I multiply first. That makes 6 plus 1 makes 7. So I have 7/3. That's the improper fraction form. So now I'm going to set up the division problem. This time I've got 3, which is the denominator, into the numerator 7 times. And 3 goes into 7 2 times. So I'm going to bring that decimal point in there and bring it straight up. And I'm going to go ahead and multiply here. 2 times 3 makes 6. So I'm 1 left over. And so I'm bringing down that 0 because I don't have a remainder of 0 yet. And 3 goes into 10. We have 3 times. And so I'm going to go ahead and multiply the 3 and the 3 makes 9. Subtract, and I'm left with 1 left over. You see, once I have that same number left over, that means it's repeating decimal. So 3 goes into 10 3 times again. So you're going to end up with the same thing. You see how 1's going to be left over again. So we can rewrite this as 2.3 repeated. And so notice how I wrote down the mixed number in this form here, 2 plus 1/3. And you see it's the same number here. So 2, we have the number 2 right here, same number we had right here, and then the 1/3 is just 0.3 repeated. So another way you could end up doing this is knowing that it's a mixed number. You know this is going to end up being in the ones place in this case. If it was 12, then we'd have a tens and a ones place. But all we'll have to really do is change this fraction to the decimal form, and doing that division would get us that same answer. So this is a repeating decimal. And these are problems similar to what you're going to see on tonight's homework. So good luck.